We will talk and practice about the intermolecular forces. Three types of the intermolecular forces to decide which molecule has a higher boiling point or lowest boiling point, or even with a melting point, which one is higher, which one is melting. By understand the intermolecular forces that exist in the molecule. Now, we have three types of the intermolecular forces that we need to study it here. The first one, it is the London dispersion forces. All molecules experience these forces. So first of all, this molecule, London dispersion forces, exists in all the molecules, all types of molecules. What is these forces? At any given instant, there may be an electron at one end of a molecule, then the other end, giving a short-lived polarity. Of course, here, the larger the molecular weight and surface area will be the greater the temporary polarization of a molecule. So look at here. Here, we have this molecule, this bond. On the molecule, what do we have? We have this electron density around the nucleus of each atom. And these electrons, they are always in movement. They're always in movement. Now, when they are in movement, at a specific moment, maybe we will have this situation. We will have this end has major part compared to the other part, which is a minor. Now, let's assume there is another molecule close to it, has the same situation. One part has the major, the other, it is the minor. And we will have attraction forces between the major part, which has the partial negative charge, and the minor will have the partial positive charge. So they will attract each other. These attraction forces we call the London dispersion forces. Now, be careful, this is temporary, because what's going to happen, let's look here, I will show you in this slide. So this is temporary, be careful with it. It will appear and disappear. So let's say, for example, we have hydrogen with a hydrogen bond. We said here at the beginning, approximately, it is 50% share, for example. Now, at specific moment, this atom on the left side will have the major, and the one in the right side will have the minor. So let's say, for example, here 70% share of the electron density, here 30%. Now, because of this situation, the one with the higher electron density share will have the partial negative, here partial positive. Now look at here. This appear here. This appear. Now it will disappear. It will go back to 50%, 50%. No partial negative or partial positive. So here disappear. Then it will appear again. It could be from here, for example. Here the 70%. Here the 30%. Here partial negative. Here partial positive. And keep going, appear and disappear. Now, if there is another molecule close to it and has this situation, partial positive, minor, partial negative. So here it will attract each other, this molecule. These attraction forces is the London dispersion forces. Now, London dispersion forces will be increased when the molecular weight increase and the surface area and has higher surface area. So for example, if I have, for example, hydrogen and which is H2 here and CH4. Both of them, here H2, both of them, they have the London dispersion forces, but the London dispersion forces will be higher for the CH4 compared to the H2. Why? Because it has higher molecular weight and higher surface area. So look to the hydrogen, will be like this, CH4 will be like this, higher surface area. And as I said, these types of the molecular forces exist in all the molecule. Okay, now let's go to the other types of the of intermolecular forces, then we will start to practice. Just want to go quickly about the second types of the intermolecular forces here. The dipole forces. The dipole forces, it is also attraction forces, and it is exists only on the molecule that contain polar covalent bond and have a net molecular polarity. So it's only in the polar molecule exists. Now, the positive and negative end of different molecules, they will attract each other. Now, maybe someone will ask, what is the difference between dipole and the London dispersion forces? There's also like partial positive part and partial negative part, they attract each other. Here, it is permanent. It's always there. In London dispersion forces was temporary. Okay, so be careful. London dispersion forces, the polarity will appear temporary. Here, it's always. And in other things, this dipole is stronger, higher than London dispersion forces. Why it's higher? Because it's always exists. So when you compare something that's always there with a temporary, it's always higher and stronger. Okay, so the same idea. We will have a polar molecule has a partial negative charge and the other end partial positive charge. Let's say this molecule was close to another molecule which has also partial negative, partial positive. So there will be attraction forces between the two opposite charge end, and we call it dipole forces. So let's say, for example, I have H2 and H2O, water. So look at here, oxygen, hydrogen, and hydrogen. Here we just have London dispersion, and here we have London dispersion, and water is a polar molecule, polar. So we will have dipole. Dipole. By the way, we have another type of intermolecular forces for the water. We will talk about it also later. But let's focus right now on dipole forces and compare it with the hydrogen. Here, because the water will have two types of the forces, London dispersion, dipole, and hydrogen H2, it's only London dispersion. Water will have stronger or higher intermolecular forces will give you higher boiling point and also higher melting point. So higher boiling point. So here the water will have a higher boiling point compared to the H2O, compared to H2. So that's what we're going to do and compare the molecule to figure out which one has a higher boiling point, which one has lower boiling point. Okay, now this is the second type of the intermolecular forces. Now let's go quickly to the third intermolecular forces, the hydrogen bond, and we will start to practice. Okay, so here. Okay, so let's go to the hydrogen bond. Now, hydrogen bond, it is intermolecular forces between a hydrogen atom and oxygen or nitrogen or fluorine, and another nearby oxygen, nitrogen, fluorine atom. So it's supposed to be hydrogen bonded to either oxygen or nitrogen or fluorine and form hydrogen bond. This is the H bond, hydrogen bond, with either oxygen or nitrogen or fluorine. So we need two situations to have hydrogen bond. Be careful, guys. We need a hydrogen bonded either to oxygen or to nitrogen or to fluorine. And they will form a hydrogen bond either with oxygen or with nitrogen or with fluorine. If we don't have this situation, there is no hydrogen bond. Now, look at here, for example. Sorry, before the example, look at here. How you will compare the hydrogen bond to other intermolecular forces. Hydrogen bond is considered also dipole intermolecular forces, but it's higher, stronger, because oxygen, nitrogen, fluorine, and it has a big difference in electronegativity with the hydrogen. So here it will be stronger than dipole and stronger than blender. So if we have molecule has only Linden and another molecule has a dipole and another molecule has a hydrogen bond, the molecule with the hydrogen bond will be higher boiling point compared to the dipole, and the dipole will be higher compared to the blender. Okay, now as I said, sometimes it's confusing for the students to find the hydrogen bond. Look at here. Not always when there is a hydrogen, that means there is a hydrogen bond. Look at here. CH4. Does the CH4 form a hydrogen bond with another CH4? We have a hydrogen, but this hydrogen can form hydrogen bond with the carbon? No. Why? Because that hydrogen bond to the carbon. We need a hydrogen bond to oxygen, nitrogen, and fluorine. Now, another thing, that hydrogen will not form a hydrogen bond with the carbon, supposed to be oxygen, nitrogen, fluorine. Now, is there any hydrogen bond between hydrogen in the water and methane, CH4? Can, for example, this hydrogen form hydrogen bond here? No. This hydrogen is correct bonded to oxygen. So we have this situation. That's correct. But we don't have the second situation or second condition, which is hydrogen form a hydrogen bond or connected to the carbon or nitrogen oxygen, nitrogen, fluorine. Here it's bonded to carbon, so cannot. Hydrogen, when it will bonded with oxygen or fluorine, this has a lone pair that will could form the hydrogen bond with the hydrogen. Here, carbon cannot form that hydrogen bond. Not only because it doesn't have a lone pair, no, because there is a small difference electronegativity between the carbon and hydrogen, so it will not form a hydrogen bond. Now let's go and start to practice with some example here. Here, what we're gonna do, we will figure out which one has higher boiling point, which one has lower boiling point. Okay, so let's say we have this molecule. I have CO, carbon monoxide, CO2, and we have ammonia, NH3. Which one will be higher boiling point? Which one will be higher boiling point? Okay. Now put CO. Guys, it's better if you will remember how to draw the Lewis structure. So CO has this Lewis structure. CO2 has this one. NH3 has this one. And it's also better to decide if you have a polar or not. Here, partial and positive, partial negative, so it will be a polar. Here, partial positive, partial negative, partial negative. They will cancel each other, will be nonpolar. Here, ammonia, but we said if there is a lone pair in the central atom, most of the time it will be polar. So here it is a polar. Okay, so we decide polar, nonpolar. Now, London and dipole, and hydrogen bond. CO, does it have a London dispersion forces? Yes, it exists in all molecules. CO2, yes, exists in all molecules. And NH3, yes. Now dipole. Dipoles exist only in the polar molecule. So here will be yes, here will be no, here will be yes. Now hydrogen bond, be careful, hydrogen bond, we need a hydrogen bonded to either to oxygen or nitrogen and fluorine to form a hydrogen bond with either nitrogen or oxygen or fluorine. So here there will be hydrogen bond for ammonia. So yes, for ammonia. CO2, we don't have hydrogen, so no. CO, no hydrogen, so no. Now, look at here. Of course, when you will compare the high boiling point to decide which one is higher, the one has more electronegativity, more intermolecular forces, more forces, higher boiling. point. So here, this one has all the three types of bond. This one has only one type of bond, which is, and don't look at here, guys. If one of, when you compare it, the dipole, it's a larger, stronger. Hydrogen bond also stronger. Don't forget this in the comparison. Okay, so here just one type, here two types. So ammonia will be higher boiling point compared to the, so ammonia will be highest boiling point. Now, the second one, so this is the first, this is the second, this is the third. Second is CO because it has London dispersion forces and dipole, while CO2 is only London dispersion forces. So that's how what you're going to do to decide which one has higher boiling point or lower boiling point when you compare the molecule. Now let's look to another example. Okay, let's look to this one. And let's see, we have H2 and H3, HF, and CH4. By the way, sometimes if you have two molecules as everything is the same, but there are differences in the molecular weight, so the one with the higher molecular weight will be higher boiling point. Also, if you have two molecules, they have London dispersion and dipole forces, both of them will go with the one that has a higher big difference in electronegativity. Also, if you have comparing two molecules, both of them they are forming hydrogen bond, you will go with the molecule that form more hydrogen bond, more than one hydrogen bond per molecule will be higher boiling point. So here, let's look for example, if we have, before I start with this chart example, let's say, what do we have? Just want to give you an example to understand how we will compare. So let's say, for example, I have let's say CH4 and C2H6. Which one higher boiling point? CH4, it just has London dispersion forces. C2H6, also no polarity, no hydrogen bond, so it will be only London dispersion forces. Now, which one is higher? It is the one with the higher molecular weight. Higher molecular weight. Let's say we have HCl, for example, and H iodide. Which one is a higher boiling point? Both of them, they have London and dipole forces. They don't have a hydrogen bond. London and dipole. Which one will be higher? The HI, because it has higher molecular weight. Okay, now let's go back to this example here. And we will make a comparison between H2O, HF, NH3CH4. Look to the difference in the boiling point. Water, it is 100. HF, 19.5. Ammonia, minus 33. CH4, minus 161.5. And if you compare the molecular weight for all of them, they are close to each other. It's supposed to be very little difference. But why we have this big difference? We will understand it in a few minutes. So look here. So when you have example like this and you try to figure out which one higher boiling point or why there is a big difference, what do we have? We have the CH4, NH3, HF, H2O. And here we have these three types of forces: London, dipole, hydrogen bond. Okay, CH4 has London dispersion forces. Yes, London dispersion forces exist in all molecules. So yes, for all of them. Now, if all these four molecules has only London dispersion forces, you will go and look for the one with the higher surface area, higher molecular weight, and it will be the highest boiling point. But here, we have some molecule have some other intermolecular forces. Dipole. Dipole exists only in polar molecule. CH4, nonpolar. NH3, polar molecule. HF, polar. H2O, polar. So here will be no, yes, yes, yes. Now hydrogen bond, CH4, no. NH3, yes. HF, yes. H2O, yes. Now we have these, first of all, CH4, it will be the lowest. Why? Because it has only one type of the intermolecular forces. Now we need to understand these three molecules. They have all three types of the forces, but water was 100 Celsius degree. Here approximately around 19 point something Celsius degree. Here minus 33 Celsius degree. So look to the difference between them. Why? Now, that's correct. All of them has a London dispersion forces. Now let's look for the dipole. NH3, HF also. They have the dipole forces and hydrogen bond. They have all of them hydrogen bond. Now the question is, how many hydrogen bonds in each molecule? So look here. Ammonia. Put another ammonia close to it. So here, how many hydrogen bond could they form? So here, that hydrogen can form a hydrogen bond with this lone pair in the nitrogen, and one here with this H bond. So ammonia will be 2 hydrogen bond. Now let's look for water. Put another water molecule here. This hydrogen can form a hydrogen bond to this lone pair, this hydrogen with this one, this with this one, this one with this lone pair. So here we have 4 hydrogen bond, 4 hydrogen bond between two water molecules. Now let's put the HF with another HF. This hydrogen will form a hydrogen bond with this one, with this lone pair, and this hydrogen form hydrogen bond with this lone pair. So we have two hydrogen bonds. So water will have 4 hydrogen bond, ammonia 2 hydrogen bond, HF 2 hydrogen bond. So we can say water will be higher because it has 4 hydrogen bonds. The hydrogen bond is a very strong bond when you will compare it to the dipole intermolecular forces and the London dispersion forces. By the way, hydrogen bond is not real bond. We call it hydrogen bond, but it is intermolecular forces. So the water, it will be the higher compared to the ammonia and HF. Now let's look at the ammonia and HF and see the difference. Here 20 Celsius degree approximately, here minus 33 Celsius degree. So why still big difference if both of them, they have 2 hydrogen bonds? What do you think? Now we have to look for the difference in the dipole forces. Hydrogen has an electronegativity 2.1, nitrogen 3.0, fluorine 4.0. Now, the bond between hydrogen and the fluorine. So the difference in electronegativity will be 1.9. Hydrogen, nitrogen, the difference is 0.9 electronegativity. So the HF will have higher polarity compared to the HN, to the HN bond or even the ammonia molecule. See, so the HF will be the second higher, and ammonia will be the third higher, and this will be the lowest. So that's how we will deal with these type of question, how to decide which one has a higher or lower boiling point.